Section 5-2, Bisectors of Triangles. The objective of this lesson will be to prove and apply properties of perpendicular bisectors of a triangle, and to prove and apply properties of angle bisectors of a triangle. We have three vocabulary words here at the beginning. We have concurrent, that's when three or more lines intersect at one point. So we say that these lines are concurrent because they intersect at one point. So these lines are concurrent when they intersect at the same point. There's point of concurrency. That's a point where three or more lines coincide. So they have a point of concurrency, that is this point right here, where three or more lines happen to intersect. This is a point of concurrency. The circumcenter of a triangle is the point of concurrency of the three perpendicular bisectors of a triangle. So if we look here, we have perpendicular bisectors. Remember, perpendicular means that it crosses at a 90-degree angle. So this red line crosses this black line at a 90-degree angle. This red line also crosses this black line at a 90-degree angle. And then here's another one. If we were to draw those lines forever, so if we draw the long lines, their point of concurrency, where they cross, is called the circumcenter of a triangle. And we're going to learn some properties on these on the next slide. Okay, we have theorem 521, which is a circumcenter theorem. Now, we just talked about the perpendicular bisectors on the previous slide. These are these lines that are perpendicular to the line, and they bisect it. Notice the two markings here, which means both of these segments are congruent. So if you draw your perpendicular bisector, where those three lines will cross, that's the point of concurrency. Now, notice we also have these blue lines right here. These blue lines have to deal with the circumcenter theorem. So notice right here it tells you that PA, this blue line, PB, this blue line, and PC, this blue line, all of these are equal. So if I told you that this measures 5 inches, you could tell me this also measures 5 inches and this measures 5 inches. They are all congruent. They are equal. Now the circumcenter can be found anywhere in the triangle or outside of the triangle or on the triangle. If it were an acute triangle, the circumcenter would be inside. If it was an obtuse triangle, the circumcenter would be outside. And if it was a right triangle, the circumcenter would be exactly on the triangle on the hypotenuse. So let's do an example here. So in our first example, we are told that DG, this line, EG, this line, and FG, this line, are perpendicular bisectors. So that means that this line right here intersects the line at a 90-degree angle, and since it's a perpendicular bisector, I know these two segments are equal. Same thing with DG. This right here is a perpendicular bisector, so that means these two are also equal. And then GE is a perpendicular bisector, so I know that these two segments are also equal to each other. Notice these numbers, they have arrows. This is pointing to this segment, and the 7.3 is pointing to this segment. They're wanting us to find GC. So GC, and I'm going to go ahead and highlight it here so we know what we're looking for, is this segment right here. Now if you remember your theorem, the perpendicular bisector theorem, it said that the segments that connect to the vertex are all congruent. So this segment and this segment, these are all congruent. So I'm going to highlight those in yellow as well. These right here, they go from the vertex. Remember, the vertex is the point. From the vertex to the point of concurrency. All of these segments are equal. So if this segment is 13.4, then this segment is also 13.4. And this segment is also 13.4. The segment that we're looking for, which is GC, this equals 13.4. So whenever you have perpendicular bisectors, the length of the segments that's created with the point of concurrency is congruent to all three. Okay, so remember that theorem. Alright, so for this one it says find the circumcenter of triangle HJK with the following vertices. So let's go ahead and plot these. We have one point at 0, 0, which is right here. One is at 10, 0, and that one's right here. And then we have one at 0, 6. Alright, so let's go ahead and connect these points here. So we've got this triangle, and we want to find the circumcenter. The circumcenter is created with perpendicular bisectors. So first, let's bisect the side. And on this triangle, it's really easy to bisect the side. I have to find the middle point here. Since this segment is 10 units long, I know that the middle point is going to be at 5 units. So right here. And I need to do a perpendicular bisector. Remember, perpendicular bisector means it crosses at a 90-degree angle. So I'm going to go ahead and do that in green here. So this will be my perpendicular bisector. Crosses at a 90-degree angle. So right here, 90 degrees. My other perpendicular bisector is going to go over here. This length right here is 6 units long. So the midpoint, the point in the middle, is going to be at 3. So I'm going to draw this perpendicular bisector right here. So do you see how the point of concurrency is going to be right there? That's where the two lines intersect. So it says find the circumcenter. The circumcenter for this one, the coordinate point was we went over 5, up 3. So it's at 5, 3. You want your x coordinate and then your y coordinate. Remember, this is the x-axis. This is your y-axis. So I went over 5, up 3. Where those lines cross, that is your circumcenter. Okay, we've got another vocabulary word. We have the incenter of a triangle. This is the point of concurrency of 3 angle bisectors of a triangle. So we have your angle bisectors. If you were to take a triangle and bisect the angles, so if I cut this angle in half with this ray, same thing if I cut this angle in half with this ray, and this angle in half with the ray. Their point of concurrency, this point right here, is called the incenter. And we have a theorem for the incenter of a triangle. Notice right here we have a clearer picture. We have our angle bisectors. Notice the markings. That tells me that the angle got bisected. Both sides of the angle are congruent. The theorem says that if you were to connect the point of concurrency, meaning the incenter, to the side, then these blue segments would be congruent. Notice the blue segments are perpendicular to the side. So if you have an incenter, then the perpendicular segment to the side of a triangle are going to be equal. Now the incenter will always be inside of the triangle, and you're going to want to remember this because you're going to see this question on the test. The incenter is only inside of the triangle. So if I have an acute triangle, notice the incenter, where the lines cross, is inside the triangle. In an obtuse triangle, the incenter is still inside the triangle. And in a right triangle, the incenter is still inside the triangle. So don't forget, the incenter is always inside the triangle. It is never outside of the triangle. So let's do a problem with the incenter of a triangle. We have MP and LP are angle bisectors. And I know it looks a little bit different here, so if we went ahead and did this. Okay, so once again, I made these lines longer so you could see that these are angle bisectors. So that means that this angle and this angle are congruent, and that this angle and this other angle over here are also congruent. And I could also draw this other one, but then it's going to get really messy, so I'm not going to draw this angle bisector. This is the incenter. It's where those angle bisector lines cross. Okay, this is the point of concurrency. Now, if you remember the theorem that we just discussed, it said that if you drew a line perpendicular from the incenter to the side, and you made it perpendicular, then that distance would be congruent to the other distances. So for example A, the distance from P to MN, so if I want to draw a line from P to MN that's perpendicular, that line's going to be about right here. I know it interferes with that line we just drew. So here's a perpendicular line. This distance from P to this line MN will be the same as this one that's perpendicular from P to ML. This is also 5 units. If I were to draw the other one that goes down perpendicular to this segment, LM, this is also 5. So 5 units, 5 units, 5 units. They have to be perpendicular. For the next one, I'm going to clear off a little bit. We want angle PMN. So here's P, here's M, here's N. Remember, so it's this angle that we're looking for right in here. So I'm going to put a little mark here. I'm looking for this small angle. Now remember, all of these lines are angle bisectors. So if this angle right here is 50 degrees, I know that this angle is 50 degrees. That means that the total for all of angle L, the total is 100. This angle is 20 degrees. We know that all three angles in a triangle total up to be 180 degrees. So right now I have 100 here and 20 degrees here. That's a total of 120 degrees. So that means that this last angle, in order to add up to 180 degrees, has to be 60 degrees. So all of angle M has to be 60 degrees. But remember, this line right here is an angle bisector. So that means this angle gets cut in half. So the angle on the left side has to be 30 degrees, and the angle on the right side has to be 30 degrees. 30 plus 30 is 60. So the measure of this angle right here is 30 degrees. I know the picture gets a little messy. You can erase when you get your worksheet, but don't forget the properties of an angle bisector and a perpendicular bisector. You've got to know the difference. Let me know if you have any questions, and try the on your own problem on your own. See if you can figure it out. Do as much as you can. Come prepared for class.